In this video, we're going to go from this base scene and use the basics of ForestPack to create this foliage-rich render. You can complete this exercise using either the Pro or the Lite version of ForestPack. The free Lite version and the exercise files are both available to download from our website. You'll find the link in the description. We're starting with a simple building and several surfaces that we'll scatter objects onto in a tiered terraced layout. There are also a few helper splines in the scene to help refine our scatters and a couple of geometry objects that we'll use as sources. The rest of the assets, or equivalents, can be sourced from freely available libraries. Let's start creating our first scatter using the fastest possible method, presets to create grass and other ground cover. To do this, click on the ForestPack icon, open the library browser and go to the presets library. Presets contain all of the models and the settings for ready-made scatters. All you need to do is to add areas. In the library there are several ground cover presets available, but we'll go for one from the Meadows category, and we want to choose one of the large versions which are optimized for covering big areas. Once selected, make sure Generate mode is active and click on a surface in the scene to create your first scatter. Now, this is a large area, so let's take a look at how we can optimize viewport performance by looking at the display settings. We're currently in Points Cloud Display mode. You can control the density of points used in the viewport using the local spinner. This view works well when you need to see an approximation of the shape of the scattered geometry. For an even more efficient mode though, you can switch to Proxy, which has several options, the most common being Pyramid mode. Below this, the max item setting limits how many objects are shown in the viewports, but this doesn't affect rendering, it's purely to maintain viewport performance. Setting this value to 0 removes the limits completely. Similarly, in the render section below, there's another max items value, and this one does control the number of maximum items that can be rendered. Again, you can set it to 0 to remove the restrictions. And that's the basics of the display modes, so let's now take a quick look at the areas rollout to remove the grass from the lake and the bottom right of the composition. In the areas list, there's a surface entry that can be toggled on or off. Let's turn it off for a moment and add a spline representing the lake. With the surface off and the spline enabled, ForestPack fills this area with objects and projects them onto the surface. We actually want the opposite of this, so instead we'll enable the surface and set the spline area to exclude mode, so it removes objects within the spline area while keeping the scatter on the main surface. Okay, so now that's ready, we can add the additional terraces. Go to the Surfaces rollout, click the plus button and select each terrace from the scene. And do this for all the remaining surfaces. Since this is a quite large environment, it creates a huge number of scattered objects. We can optimize performance using the camera rollout. When you enable limit to visibility, by default ForestPack detects the active camera automatically and restricts scattering at render time to only what the camera actually sees. You can also specify a specific camera by simply selecting it from the scene. You can enable limit display to viewport to preview the effect interactively. For static renders, this makes viewport performance much faster, though it's not always recommended for animated cameras. Finally, if you look closely at the building, you'll notice the grass is appearing beneath it. We don't want that. You could exclude the building using a spline, just like we did for the pond, but ForestPack allows you to exclude geometry directly. In the Areas rollout, add an object area, then pick the building. You'll see the grass automatically removed from beneath it, no spline required. Now we have our base grass scatter in place using presets, surface controls and basic area exclusions. In this section, we'll move on from presets to use individual 3D assets from the ForestPack library to populate the trees in the background of our scene. To start, create a new ForestPack object, open the library browser and go to the 3D section. Browse through the available tree models and select a few you like. Set the mode to Generate, then click on the topmost surface in the scene to scatter the trees across that area. Next, open the Modify panel and go to the Surfaces rollout. Here we'll add the terraces, but this time instead of adding them one at a time, open the Add Multiple dialog box, select the surfaces from the list and add them all at once. As you can see, the trees now dominate the scene and many are too large for the surfaces they're sitting on. This happens because ForestPack uses each object's pivot point to determine whether it's on a surface, without taking size into account. We can fix this by changing the mode in the areas rollout from pivot to size. When this mode is active, ForestPack checks the size and the width of each tree to see if there's enough space before placing it. Now that's working correctly, you'll notice that some trees are scattered in places where the house should be. To remove them, go to the areas rollout, add a spline area, pick the spline from the scene and set it to exclude. Next, you'll notice that all the trees, even in pyramid display mode, look very repetitive since they share the same rotation and scale. We'll fix this in the transforms rollout. Turn on rotation randomization and slightly increase the X and Y rotation ranges. Then enable scale randomization, adjusting the minimum and the maximum values to create variation in tree sizes. Nearly there. Now let's refine the overall distribution. Go to the distribution rollout where you'll find several ready-made distribution maps that define different scatter patterns. You can switch between these to test how they affect the layout of your scene. To control how large the distribution map appears, adjust the density value until the spacing looks about right. Finally, to see which tree types are being scattered more clearly in pyramid mode, go to the geometry rollout and set color IDs for each of the plants. Each model will then display in a different color, making it easy to distinguish between them. This is especially helpful when adjusting the probability parameter, which controls how likely each tree is to appear. The color IDs make those changes immediately visible in the viewports. Now that we've covered how to load objects from the ForestPack library, let's look at how to scatter objects directly from your scene. This means you can use models from any source. In this example, we'll use a couple of tree models imported from the Chaos Cosmos library. After importing them, make sure they're selected and then click to create a ForestPack object. Right-click on the Open Library button to clear the existing selection and enable Populate from Selection. When this option is turned on, ForestPack creates a scatter using whatever objects are currently selected in your scene. Next, switch to icon mode and click and drag in the viewport to create a new ForestPack icon. This lets you create a ForestPack object without assigning any surfaces or areas yet. You can add them later. Now, go to the Surfaces rollout and use the Get from Selection option to pick another ForestPack object from the scene. This links the new ForestPack to the same surfaces used by the selected object, meaning if you change the original, both will update automatically. Go to the Areas rollout and enable Surfaces to view the scattered results. Let's refine this setup by adding a few new areas. First, add a new spline area, pick the spline that surrounds the top terrace and set it to exclude, so the smaller trees don't appear in the same zone as the large background forest. Next, set the boundary checking mode to size to make sure trees are only placed where there's enough room. Add another exclude area and then pick the spline around the house the same way as we did before to keep trees from overlapping the building. To remove visible repetition, enable rotation and scale randomization in the transform rollouts. And then go to the distribution rollout and slightly adjust the density to create a more natural, open layout. If you find the collision radius around the trees is too large and you're not getting any trees on the terraces, simply open the geometry rollout and here you can reduce the collision radius for each plant individually. This allows you for finer control and a more organic result where branches slightly overlap. Now, let's switch to the camera view so we can take a look at the composition. You might notice there are a few trees partially blocking the building. To fix that, we can select and edit the spline used to exclude the house. Just adjust the corner vertices to remove those trees from view. This demonstrates one of the key advantages of ForestPack. It's fully procedural. You can adjust any spline, any surface or parameter at any point and your scatter updates instantly across the entire system. Switching back to the camera view, we can see the layout now looks much better. And finally, let's switch to points cloud display mode to get a better sense of the actual tree shape so you can check that nothing is obscuring the main structure in the final composition. Sometimes, after scattering trees, you'll want to manually adjust individual ones to refine your composition, instead of relying entirely on area-based distribution. This is where Custom Edit Mode comes in. Custom Edit Mode lets you place, move, or remove individual items inside a ForestPack scatter, giving you full manual control while keeping everything within the same system. To use it, start by creating a new ForestPack object in Icon Mode and pick the tree assets from the scene. Then open the Surfaces rollout and use the Get from Surface option to link this ForestPack object to another existing ForestPack object. In this case, we'll link it to the grass layer that uses all of the terraces. We obviously don't want trees appearing in the lake area, so let's add a spline area, set it to exclude, and select the spline that defines the lake. Now let's switch to camera view so we can evaluate the placement. Increase the points cloud density slightly to make individual trees easier to see. This helps when refining this overall composition. Then let's open the transform rollout and apply some rotation and scale randomization. You'll see a common workflow starting to emerge here. Head into the distribution rollout and adjust the density to achieve a balanced tree coverage. At this stage, the scatter looks good overall, but a few trees are obscuring the view of the house, which should remain the focal point of the shot. Rather than setting up more include or exclude areas, we can now switch instead to custom edit mode. Once custom edit mode is active, go into the item sub-object level. Here you can select and delete individual trees directly in the viewports. You can also move, rotate, and scale them to fine-tune your scene. For example, in the bottom right-hand corner, we'd like to add a tree here to help frame the composition. As you can see, we can rotate it slightly and scale it a bit to strengthen the view. Custom edit mode is perfect for these kinds of final tweaks. It combines the efficiency of procedural scattering with the flexibility of manual placement. Now that most of our main scatters are in place, let's add a few more layers of ground cover to bring extra detail and variety to the scene. We're also going to use this as an excuse to look at one of ForestPack's oldest but most useful features, clusters. Clusters groups plants of the same type together instead of scattering them in a completely random, noisy way. It produces a more natural result that mimics how plants actually grow in the real world. In this example, we'll use 3 plant models from the 3D Garden sample library, but you can use any asset you like from any source. Start by creating a new ForestPack object in icon mode. Then go to the surfaces rollout and use the existing surfaces from the grass scatter. Enable surfaces to view the distribution. At first the scatter might look sparse, so open up the distribution rollout and change the distribution map to patches. This gives you a more interesting distribution with areas of dense growth and open gaps. But they're possibly a bit spread out, so you may need to lower the density value to balance the look. If plants start disappearing while adjusting the density, if you remember from the beginning of this tutorial, that's likely because the max items value in display settings is still limited to 5000. So if you set that value to 0, you can see the full scatter in the viewports. Now let's switch to proxy mode for easier visualization, and before continuing with distribution, let's visit the geometry rollout. You'll see that each of the 3 scattered items has a different color ID. These color IDs are automatically assigned and they define how ForestPack groups plants into clusters. So objects with the same cluster ID belong to the same cluster while different IDs create separate ones. Now, let's go back to the distribution rollout and enable clusters to see this in action. You can immediately see how the colors define each cluster group. The current cluster size is quite large, so let's reduce the cluster value until you get smaller, more natural patches. You can also use the settings here to introduce some noise, for example around 10% to break up the uniformity, and adjust the edge blur to soften the edges between clusters. Next, scroll to the collision settings at the bottom of the rollout. We're using 3 plant types and they're very different sizes, large pink shrubs but much smaller blue ones. When plants vary in scale like this, an even distribution can be tricky. To handle this, enable the collisions, but make sure that you've set the distribution scale to use the smallest possible plant size. This will remove overlapping larger plants while keeping the smaller ones in place. If it feels too strong and you find too many plants are being removed, reduce the collision radius to about 50% for a more balanced result. It's also useful to enable viewport preview here so you can see these adjustments interactively. Okay. So we don't want any of these shrubs growing in the lake, so let's add a new spline area, set it to exclude and select the lake spline. Next, we'll clear some shrubs from beneath the trees. This is a unique feature. ForestPack allows one scatter to exclude another, so you can use the tree scatter as an exclusion object for the shrubs. It's great for realism since plants don't usually grow densely under tree canopies. Once you've added a ForestPack object as an exclude object, you'll find a scale control that adjusts the collision volume of the trees, increasing or decreasing how far the exclusion reaches. Finally, in the foreground of our render, there's a pathway where we don't want shrubs to grow. To fix that, create another spline area and then select the red path spline and set it to exclude. Since this spline is open, it has a thickness parameter that controls the distance to either side of the spline from which plants are removed. As you increase the thickness value, you'll see the shrubs move back, clearing space for the pathway. So far, we've worked with areas, splines, surfaces, and object areas to include or exclude objects from scatters. Up to now, these areas have behaved in a simple way. An item is either inside or it's outside the area. But ForestPack also includes advanced controls that let you blend or soften the boundaries of those areas. These are called Falloff curves. They allow you to gradually change properties such as density or scale based on the proximity to an area's edge. This gives you a far greater control and more natural transitions. Let's take the grass ForestPack object as an example. If we select this scatter and add the red spline, the path spline, as a new exclude area, you can then increase the thickness parameter, as we saw in the previous example, to pull the grass back from the edge. But it's still a hard, abrupt boundary. To soften that transition, scroll down to the Falloff section. Enable Density Falloff, and then click on the button to open the curve. On this graph, the left side, 100%, represents the full density of objects farthest from the area boundary, while the right side, 0%, represents the edge of the area itself. As you adjust the exclude distance, this curve controls how gradually the density fades from full to none. Now, instead of a sharp cutoff, the grass thins out smoothly as it approaches the spline, making a much more natural result. Alongside the density falloff, there's also scale falloff, which adjusts the size of objects based on their proximity to an edge. Open the curve and you'll see the same logic. 100% scale to the left, tapering down to 0% on the right. Now typically, you won't want objects to completely disappear through scaling, so raise the right hand side of the curve slightly above 0. That way objects near the boundary become smaller, but don't vanish completely. As you adjust the exclude distance, you'll notice the pyramids get smaller along the edge. In some cases, this can look a little bit unnatural. This is a ground cover preset designed to fill the area without gaps, and tiny tufts of grass shrinking to the points break that illusion. A better approach with these kinds of presets is to enable effect height only. When this is turned on, instead of shrinking completely, the grass flattens as it approaches the path, to create a realistic trampled look, as if the grass has been pressed down rather than erased. Adjusting the exclude value lets you control how far from the center of the path this effect occurs. In this section, we'll look at how to use open splines more effectively and how to make closed splines behave like open splines. We'll apply this to create a path made from stepping stones and then add rocks around the edge of the lake. Let's start with the stepping stones. Select the rock assets already in the scene. Enable Populate from Selection and switch to Icon mode and draw a new ForestPack object. In the Surfaces rollout, add the bottom surface. This represents the area where the path sits. For this example, the surface is flat because we're working with Forest Pack Lite, but it doesn't have to be. Now, add the path spline, it's an open spline, to the areas list. Turn off surfaces since we don't want the rocks scattered across the entire surface, only along the spline path. Then set an appropriate width value for the open spline and adjust the density to control how many rocks appear and achieve an even, natural stepping stone pattern. Now let's go to the transforms rollout. Turn off X and Y rotation so the rocks lie flat against the ground. Keep Z rotation active for random variation around the vertical axis. Under scale, set the minimum to 90% and the maximum to 110% for subtle size variation. Now we're going to change the lock aspect ratio option to XY only. This allows separate control over XY and Z scaling. Now let's reduce the Z scale to flatten the rocks into disc-like shapes, perfect for stepping stones. This is a handy trick when you only have general rock models instead of purpose-made slabs. Okay, the layout's looking good, but some rocks may overlap too much. So to fix this, just like we did before, we'll enable collisions and preview them in the viewport. Lower the collision radius slightly so there's a small amount of overlap without excessive interpenetration. Next, in the areas rollout, enable scale falloff and reduce the scale near to the edges to around 40%. This makes rocks in the center of the path larger and those at the edges smaller, giving a more natural transition. You can fine-tune that by adjusting the falloff curve. Now let's add rocks around the lake. We'll use a similar process starting from the same rock assets and the same Forest Pack setup. We'll add the bottom surface again, enable surfaces, and then go to the transform rollout to randomize rotation and scale. Now let's open the distribution rollout and set the mode to full and adjust the density until the rocks cover the area nicely. Still in the distribution rollout, enable collisions and tweak the radius to maintain a good balance, enough coverage without the rocks intersecting too heavily. Once that looks good, disable surfaces, since we only want rocks around the lake's perimeter, not across the entire bottom of the surface. Add a new spline area. Select the lake spline and set it to include. By default, as you'd expect, that fills the entire enclosed area with rocks, but we only want a border around the lake. To achieve that, enable the Force Open Splines option. So now, even though the spline is technically closed, it behaves like an open spline, allowing you to scatter along its perimeter and increase the thickness until you get the desired band of rocks along the lake's edge. To make the transition more natural, enable Density Falloff. This softens the boundary, gradually reducing the number of rocks the further they get from the lake. Adjust the include distance to fine-tune the width of that gradient, and then enable Scale Falloff and modify the curve so that the rocks get smaller as they move away from the lake's edge. Increase the include distance again for the scale to spread out the scale change over a comfortable distance. Now let's look at this from the camera view. We can see the lake rocks blending naturally into the landscape, but some of the rocks are overlapping the pathway. So let's add another open spline area and use the path spline as an exclude area. Increase its thickness just enough to keep that path clear. And then finally, to clean things up further, we could exclude any rocks that appear beneath the shrubs. And to do that, we'd add a forest exclude area, pick the shrubs forest pack object and adjust the scale of the exclusion size as needed. This gives you a realistic interconnected setup with flattened stepping stones along the path and naturally distributed rocks following the lake's edge, both controlled precisely using open splines and fall-off effects. To finish this tutorial, we'll look at one more type of area we haven't covered yet: paint areas. Paint areas in ForestPack are quite special. Unlike many other scattering tools, they remain fully procedural, meaning you can edit or modify them at any time without losing your work. Let's add a few bamboo plants using this feature. We'll use a few models from the third-party library. With them selected, start by creating a new ForestPack object, and in the surfaces rollout, add the bottom few surfaces, maybe the lowest 3 of the tiers. Now, go to the areas rollout and turn off surfaces display, since we'll be painting directly on top of those surfaces. It's important to remember though that you must have surfaces added in order to paint. The paintbrush needs a surface to project onto. Now, click Add New Paint Area, and then click on the Paint button to begin. You can control the brush size using the brush size parameter. Simply paint in the viewport to add plants wherever you'd like them to appear. If you've made a mistake, you can click the Eraser tool and paint again to remove unwanted errors. It's completely interactive. One of the biggest advantages of paint areas is that you can paint from your camera view. That makes it easy to place vegetation precisely where it complements your composition. You can literally paint your final frame, filling only what's visible to the camera. This flexibility makes paint areas perfect for artistic control and fine-tuning. Once that's done, we're ready to render the scene and see the final composition. So having completed this tutorial, you've used many of the core features of Forest Pack Lite and Pro, from presets and volumes to custom areas, clusters, fall-off, paint tools, and much, much more. These techniques should give you the strong foundation you need for working with Forest Pack. But if you have any questions, please get in touch. We're always happy to help. And stay tuned for more in-depth training courses soon, where we'll cover advanced Forest Pack Pro features in much more detail.